right, so let's look at an actual example. It says a survey of 1,000 U.S. gas stations found that the price charged for a gallon of regular gas could be closely approximated by a normal distribution with a mean of $3.10 and a standard deviation of 18%. Okay, this is not in the book like this. In the book, it does not have you draw the bell curve, and that is the first thing that I want you to do on every single one of these problems. So when you're doing your homeworks and your quizzes in WebAssign, it is not going to have you draw the bell curve, but it is extremely important that the first thing you do on these types of problems is draw that bell curve. I want you to label the percentages and the tick marks of every single one of these, okay? Remember, the percentages never change. The percentages are always going to be the same. So let me start with the percentages right here. I'm going to do all my percentages in blue. If we do the percentages from the previous page, these are always the same as long as it's normally distributed. We know the tails are 0.15%. Okay. We know the next section is, let's go back to it. The next section is 2.35%. The next section is 13.5%. On both sides, remember it's symmetric. And the middle sections with the most represented 34% of the data. That is always the same. That's what should be on your note card. Okay? That's always the same. That's what should be on your note card. So now the question becomes, how do I do the actual tick marks? Well, you always start with the mean. The mean here was $3.10. And then what you're going to do is you're going to keep on adding and subtracting the standard deviation. So for instance, to the right of $3.10, I'm going to add 18 cents every single time. Well, let's see what we get when we add 18 cents every single time. I think I would get $3.28 for the next one, $3.46 for the next one, and $3.64 for the last one on the right. Let's do 310 minus 18 cents every single time. I'm getting $2.92. Subtract 18 again, I'm getting $2.74. Subtract 18 again, I'm getting $2.56. So all I did was I took the percentages, which are always the same for a normal distribution, put that on your note card, label all those percentages, and then I'm starting with the mean, I'm adding the standard deviation and subtracting the standard deviation. That's how you create the bell curve for this graph. If you have the bell curve, you're done. That's going to answer every single one of the questions from here on out. You just have to add the percentages together. So for instance, it says how many scored between, I'm going to use, how about the pink on this one, between 274 and 346. So here was where 346 was. Let me clean that up and make sure it looks like a 6. So that's the 346. So the question is, how many scored between those? Well, all I have to do is go in and add those percentages that I see. So the first percentage group I see is a 13.5. I see a 34. I see a 34. And I see a 13.5. Okay? When I add those percentages together, what do I get? Use your calculator and do so now. Adding those percentages together, I'm getting 95%. And I'm going to reread the question. How many stations charge between this? But this is 95%. Now, I don't know if they wanted a percentage here or if they wanted a quantity here. So the answer is 95% of the gas stations, but what if they wanted the quantity? What would you do? Well, you would have to do 95%, which is 0.95 times 1,000. And if you do 0.95 times 1,000, you end up with 950. So if they wanted the percentage, you would say 95%. If they wanted the quantity, you would say 950 stations. I'm not sure what they want in this one. I answered it with the percentage, but I just want you to know if you didn't get the percentage, if they actually put a number, that's how you would get the number instead. So the percentage should be fine here. It's not clear in the directions which one they wanted, but that's how you would get the answer. Okay, so now it says how many scored less than 328 for regular gas. So let me come in here. I'll use blue on this one. Here's 328. Let's look at 328. So what's the idea? I'm going to add all of them up to 328. Don't forget that tail end at the bottom. That's what most students forget. So what would I have? I'd have 0.15 plus 2.35 plus 13.5 plus 34 plus 34. That's all the percentages from the very bottom, which would be 0, all the way up to $3.28. Add those together now. Let's see what you're getting. I'm getting a total of 84%. Or if we did 0.84 times 1,000, we would have 840 stations. So depending on which one they wanted, there's the percentage and there's the quantity. Okay. Now it says how many charge more than 346 per gallon. I'll use a different color. How about green on this one? So here's 346, and they're wondering how many score more than that. All you got to do is add your percentages. 2.35. 2.35 is the first percentage, plus 0.15. Again, never forget that tail end. 2.35 plus 0.15. I'm getting a total of 2.5%. 2.5%. So again, or you could do the it's 0.025 times 1,000, and that would represent, what, 25 gas stations? So 2.5% or 25 gas stations. Again, how did I get the quantity? The only reason I was able to get the quantity is because it said 1,000 U.S. gas stations. So if we were talking about the quantity of those gas stations, we would use the quantity. But if we're talking about the percentage, thinking that this is a sample of the entire set of the United States, we would leave our answer is the percentage. So you could say 95% of gas stations across the U.S. charge this much, or 84% across wherever region they're talking about. Okay, so it depends if they're saying the 1,000 is a sample or the population. If it's the sample, you use the quantity. If it's the population, you use the percentage. Okay, so I hope that helps. It always start with that bell curve. Start with marking the mean, add and subtract the standard deviation to get the other tick marks, and then you always have those percentages between each of those loops as long as it's normally distributed.